Have you ever wondered if computers can think like humans? Well, imagine sitting down for a conversation and not being able to tell if you're talking to a computer or a real person. Welcome to the mysterious world of the Turing test, a test that challenges our understanding of what it means to be intelligent. In this video, we'll dive into the fascinating history and mechanics of the Turing test and explore the implications of its potential success or failure. Alan Turing was a British mathematician and computer scientist who is considered one of the pioneers of modern computing. During World War II, he played a critical role in breaking the German Enigma code, a feat that many historians believe helped shorten the war. After the war, he continued to work on computer science and artificial intelligence, proposing the concept of a universal machine that could mimic any computing task. He is now widely recognized as a visionary thinker and an important figure in the history of computer science. The Turing test is a way of testing a computer's ability to exhibit intelligent behavior that is indistinguishable from that of a human. The test works by having a human evaluator engage in a natural language conversation with a machine and a human, without knowing which is which. If the evaluator cannot reliably distinguish the machine from the human, then the machine is said to have passed the Turing test. The Turing test was created as a way to explore the question of whether machines could be considered intelligent. Turing believed that if a machine could pass the Turing test, then it would be reasonable to say that it was capable of thinking and exhibiting intelligence. The test has since become a popular way to evaluate artificial intelligence and has been used as a benchmark for measuring progress in the field. The Turing test works by having a human evaluator engage in a natural language conversation with a machine and a human, without knowing which is which. The test is typically set up as a competition between a machine and a human, with the evaluator tasked with determining which is which based solely on their responses to questions or prompts. To administer the Turing test, the evaluator is typically placed in a separate room from the machine and human participants and communicates with them through a text-based interface, such as a computer terminal or chat window. The evaluator is free to ask any questions or make any statements they wish, and the machine and human participants respond as they would in a normal conversation. The goal of the Turing test is for the machine participant to be able to convincingly simulate human-like conversation, to the point where the evaluator cannot reliably distinguish the machine from the human participant. The machine is said to have passed the Turing test if it is able to fool the evaluator into believing that it is human more often than not. The Turing test is designed to test a machine's ability to exhibit intelligent behavior that is indistinguishable from that of a human. This includes not only the ability to understand and respond to language, but also the ability to reason, learn, and exhibit creativity. The evaluator is looking for evidence of these abilities in the machine's responses, such as the ability to understand and appropriately respond to sarcasm or irony, or the ability to generate new ideas or make unexpected connections between concepts. While the Turing test is a widely recognized benchmark for measuring progress in the field of artificial intelligence, it is not without its criticisms. Some of the main criticisms of the Turing test include its limitations and the difficulty of interpreting its results. One limitation of the Turing test is that it only measures a narrow range of intelligence, namely the ability to simulate human-like conversation. This means that a machine could pass the Turing test without actually exhibiting any real intelligence, such as the ability to reason, learn, or solve problems. Another limitation of the Turing test is that it can be biased towards certain types of machines. For example, a machine that is specifically designed to mimic human-like conversation may be more likely to pass the Turing test than a machine that is designed to perform a different type of task, such as playing chess or driving a car. Some critics also argue that the Turing test sets an unrealistic standard for measuring intelligence by requiring a machine to perfectly mimic human behavior. They argue that this standard is unnecessary for creating useful and effective artificial intelligence, and that other measures of intelligence should be considered instead. In conclusion, the Turing test is a fascinating and important concept in the field of artificial intelligence. While the Turing test has its limitations and critics, it remains a valuable tool for evaluating progress in the field of AI, and has sparked important debates about the nature of intelligence and the ethics of creating machines that can mimic human behavior. We hope this video has provided you with a clear and accessible introduction to the Turing test, and that you have gained a deeper understanding of its significance in the world of artificial intelligence. Thank you for watching, and we look forward to exploring more exciting topics with you in the future.